Yo, what is good, guys? This is Theo here, and in this tutorial, we are going to explore the basic introduction to recursion. So, I'm going to use two examples, and we're going to explain actually what's happening behind the scenes with the call stack. And so, yeah, let's get to it. So, I think we'll use three examples actually. So, I'm going to start from easy to more difficult. Okay, the first one we're going to build out a function. Okay, let me switch this to JavaScript. And so we're going to build this function out. Let me put this in full screen. Okay, so we can build out this function, and we're going to call it recursive sum. Let me change the tabs to 2. So we'll say recursive sum. And this is going to take in an array, okay? And what are we going to do here? So the first thing when we create a recursive method is we have to define our base case. So what does this actually mean? What is this terminology? This means the condition that will end our function calls. Okay, so that's what it means. So here the base case is, right, say we have an array, and what we want to do is get a sum returned, right? So how can we break out of this? First thing that came to mind for me is, and it might not come quickly for everyone, I'll be honest, I'm still, learning this myself, but the first thing that came to mind to me was this. So our base case could be if array.length is less than 2, okay? If we just have an array of 1 at this point, then let's go ahead and return our array, okay? And I think we're going to need to return array of 0, but let's just try with array, okay? Next up, right, if it isn't less than 2 and we have a full-fledged array, right, so we have, some sample data here, and we have 1, 2, 3, 4, 5, then what do we want to do? Well, what we can do actually is we can do this. We can call our method, okay, but instead of passing in this array again, which is just going to end in an infinite loop, or it won't end rather, what we can do is we can say return array of, okay, what do we want to return? We want to return the array of 0, the first element, plus the result of recursive sum on array dot splice. And what do we want to do? We want to splice out, we want to splice 1 to array.length minus 1. So this will now basically get rid of this first element up until the end, okay? So let's go ahead and try this out. Let me make sure it builds. I don't get any errors in the function. So we're going to call recursive sum, and we're going to pass it this array of 1, 2, 3, 4, 5. Run it through our build system, and no errors so far. So actually what we want to do is create a variable called sum, and let's just log it out to our console. Okay, let's look at what we're getting. So we're getting 1, 2, 3, 4, 5. So we're getting there, but we actually have an error. So let's try and return array of 0. Get rid of that, run it through our build system. Now we've got 15, okay? So let's add these up. So 5 plus 4 is equal to 9. 9 plus 3 is equal to 12. 12 plus 2 is equal to 14. And 14 plus 1 is equal to 15. Just to try it out, with a simpler case, do 1, 2, 3. And this time we should expect 6. There we go. So this has actually worked, okay? So I'm going to explain how this works. But the general idea is, and you can sort of see we need to return this array of 0 because that's going to be our final sum. So what we do here basically is, let me illustrate this for us. So I have here stack calls, and what I want to do is I want to comment this out. Okay, so first, right, so we have 1, 2, 3. And our first call to our stack, what's going to happen is we are going to have we're going to pass in 1, 2, 3. Is it less than 2? No. And then what we'll return next is return array of 0. Okay, so what's array of 0? We're going to return 1 plus, okay, recursive sum of array.splice. Splice mutates the array. And what's array.splice of 1 to the array length minus 1? Okay, so that actually is this new array of 2 and 3. Okay, so that's our first call. So this is being added to our stack right there. So basically we can think about it like this, right? We have this, variable stack, and what will happen here is, we'll push this onto our stack. So right now we just have, 1 plus recursive sum of 2, 3. 2, 3. This is how I can visualize it. And next up, we have a second call to our stack. And what will be passed in here is 2 and 3. Is this less than 2? No, it is not. So in this case, we're going to return, what are we going to return? We are going to actually return the array of 0, which is 2 plus recursive sum of array.splice 1 and array.length minus 1. So in this case, we are just returning an array of 3. Okay, and now our stack is going to look like this. It's going to look like 1 plus 2 plus recursive sum of 3. Next up, our final call to our stack. It's going to look like this, right? So we have a value of 3. Is this less than 2? Yes. Okay. So now what we want to do is return array of 0 here. So what is array of 0? Well, array of 0 here is 3. So now we've added that onto our stack. And what we have now is 1 plus 2 plus 3. And this will finally evaluate. Okay. So now we're returning 1 plus 2 plus 3. And we're going to return 6. So that's how I visualize it with the stack. Hopefully that helps. Now that we've seen that, let's build out another method. And this time we're going to implement the factorial method, which is very common. And this one, as you might imagine, will take in a number, which we can represent with n. And here we can write our base case, and we could say if n is equal to 1 or n is equal to 0, let's go ahead and return n. Otherwise, this is where we'll perform our recursion, and we can say return n. So in this case, basically, going back to, what a factorial is, a factorial, if you do 5 bang, that's actually going to be 5 times 4 times 3 times 2 times 1. So it's the number multiplied by every number below it all the way until 1. So in this case, we can really just do that. We don't need 0. So we're going to return n times factorial. We're going to call the function again. And so that we can break out of this eventually, we're going to decrement n by 1 each time, right? So this will give us, 5 times factorial of 4 times factorial of 3 times factorial of 2 times factorial of 1. And if it's equal to 1, again, we're just going to multiply it by itself, add that to the stack, and break. So let's look at this, right? Say we pass in a number of 5. So n is equal to 5 here. And our stack calls will look like this. Our first pass to the stack will be like this. We pass in 5. Is it equal to 1? No. Then what we can do is we're going to return 5 times factorial of n minus 1. So we're going to return 5 minus 4. So factorial of, 5 minus 1. And then we can, our stack, right? Our stack is going to be, we're going to create this again. Our stack is now going to look like 5 times factorial 4. Our second call, you can sort of see where this is going. It's going to be 4. Is this equal to 1? No. Doesn't meet our base case. Let's now return 4 times the factorial of 4 minus 1, remember, n minus 1. And now our stack, we'll push this on to the call stack. So now we have 5 times 4 times factorial of 3. Next up, we have our third call to the stack, and we have 3. Is this equal to 1? No. Then let's go ahead and return 3 times factorial of 3 minus 1, which is just 2. And now our stack will look like this: 5 times 4 times 3 times the factorial of 3 minus 1, which is 2. Our fourth call to the stack will be 2. Is this equal to 1? No. So let's go ahead and return 2 times factorial of 2 minus 1. And now our stack is almost done. So we have 5 times 4 times 3 times 2 times factorial of 1. So now our fifth call, our final call to the stack with factorial of 5 will be 1. Is that equal to 1? Yes. Then let's go ahead and return n. So let's go ahead and return 1. So now our stack looks like 5 times 4 times 3 times 2 times 1. And now we should just return 120. And with that, let's go ahead and try this out and see if it works. So we can say console.log factorial of 5. Run this through our build system, and we get 120. Awesome. And now, similarly, if we were to do 2, we're going to get 2 back. If we did 3, we should get 6. And 4, I believe, is 24. 5 is 120. 6, 720, so far, and going up. But 5 is our example. Okay, so our final example that we're going to be doing is a recursive string reversal. Actually, I think this is a really good example. So what we can do, let me get rid of this and bring this up for stack calls. So basically, the idea here is going to reverse our string in place pretty much. Okay, so what's our base case going to be here? Well, our base case is going to be if our string dot length is equal to 1. Let's go ahead and return our string. Okay, so a lot of these have a similar pattern. We're just checking for this base case at 1 or 1 digit, whatever, and then we're going to break out. Otherwise, what I want to do is I want to return the string dot substring. We want to get a substring of the string from what do we want to get? We want to get string dot what do we want to get? We want to get string dot let me think about what it is. It is going to be, so if not, we're going to pass in, we're going to call recursive reverse with the string dot substring, and in this case we want I'm trying to think what it is. We're going to want the string dot caret what do we want? We want the string of caret 1 all the way until the string dot length minus 1, and then we're going to add that on with the string at car at 0. So let me explain this. Let me make sure this works, and then I can break it down for everyone. Okay, so let's try this. Say var word is equal to zombies, and then we can console.log recursive reverse word, and what do we have here? Unexpected token. Okay, not bad. And we're getting z. So I've messed up a little bit. Let me see. Return string 0. Okay, so must have made a little bit of a mistake here. So what we want to return, similarly to our array, is we're going to return recursive reverse of, we want to return recursive reverse with, string, what do we want to return? String dot, what can we do? We can do slice from 1 to string dot length -1 plus string dot car at 0. I think that should work actually. bmos. It's close. bmos string dot slice 0. What is it? No, I'm getting close. So recursive reverse string dot length string dot slice substring. Okay, I think, yeah, substring, yeah, that's why. Because, yeah, I think with slice, yeah, let me try. I don't know if this, does it have a slice? Yeah, I don't think splice, yeah. So we need substring. Let me try that. Not substring, but substring. Okay, so that works, and just to prove it, we can change this to hello, and now we get ole, and, maybe dogs is God, or, mom should still be mom. But we'll just try it with hello. There you go. So basically what I did, this one is a little bit trickier, and we can walk through the stack, but basically this substring is like the array splice, and then it's going to mutate the string, or it's going to return to us a new string rather, each time. So this first time we'll walk up to our function with hello. Is it equal to 1? No. But what we can do is actually add on, here this substring method, which goes from 1 because we want to store our last character at the end each time. So we're going to go from the next character 1 up until the length. So let me break this down with sort of the stack trace right here. And keep doing that wrong. And so let's look at this. Go stack calls. So our first time through the stack, let's say var stack equals an empty array. First call, we'll come in here with hello. Is it equal to, so first time we have hello. Is it equal to 1? No. Then we want to return recursive reverse with string substring of 1, string minus length 1, which is actually just going to default to hello, plus string dot character at 0. This is the same as string of 0, and this is actually just going to be h. So now our stack is going to look like whatever recursive reverse of hello plus h is. So we can sort of see this is added to the back. Our second call to the stack is going to be with hello. Is this equal to 1? No. Then let's go ahead and return recursive reverse with what we want to do now is going to be low plus e, because that's the first character. Our stack will now look like this. It's going to be, it will now be recursive reverse of low plus e plus h. Our third call is now going to be low. Is this equal to 1? No. And let's return recursive reverse of, now it will be, it's now going to be low, okay, with L as the first character. And now our stack will look like this. It's going to be recursive reverse of low plus L plus E plus H. Okay. Our fourth call to the stack will be low. Is this equal to 1? No. And let's go ahead and return recursive reverse with, in this case, L, or sorry, in this case, O, and then L will be our first character there. So now our stack will look like this: recursive reverse of O plus L plus L plus E plus H. Finally, our fifth call to recursive reverse will look like this. Oh, is this equal to 1? Bang, we hit our base case, and now we can return, we're just going to return that actual string, or you could do string of 0. I think either one works. Either one works. So we can return the string as well, it doesn't matter, or string of 0. And in this case, we're just going to return O. So now our stack looks like this. It's going to be O plus L plus E plus H. And our final product will just be this string of ole. So that was a very basic, gentle introduction to recursion in JavaScript. Hopefully you guys enjoyed it. If you did, make sure to like, comment, and subscribe. And I will see you guys in the next video. Take care.